All right, guys, this is section 3.4, part 2, and then there's one more part, part 3. Okay, and all the rest, part 2 and part 3, are all word problems, and they all deal with quadratic equations. Okay, so 3.4 part 1, we just got familiar with quadratics, and now we're going to see them in word problems. Okay, this note sheet, I might do a part A and part B. We'll see how far. Anything past a half hour gets a little long. But this one note sheet is for April 6th and April 8th. Okay, and so there's one homework assignment. But these are a little bit harder, so it might take you a little bit longer. So I allowed 2 days for this. Okay. All right, so let's just start reading it and going through it. If a rock is thrown downward with an initial speed of 32 feet per second, the distance d, so d is the distance that the rock is traveling. You give me 5 seconds, t is seconds, 5 seconds, I'll tell you how far it's traveled. 10 seconds, I'll tell you how far it's traveled. Okay, so t seconds is given by this formula. D is how far the rock has gone. T is how many seconds it's been. Okay, if the rock is thrown from the top of a tower, okay, that is 45 feet tall, how long does it take for the rock to strike the ground? Okay. All right, so we've got this tower that's 45 feet tall. Okay, it's thrown, the rock is thrown downward. Okay. And then we want to know when it hits the ground. D is the distance that it's traveled, and T stands for time. Well, I know the distance. How far did this rock go if it was a 45-foot tower and we want to know when it hits the ground? How far did it travel? It traveled 45 feet. So the distance is 45. And the question says how long. As soon as the question says how long, you're always solving for t. How long is time? How long did it take for the rock to hit the ground? This is a quadratic equation, guys. These numbers are maybe a little bit bigger, but this is what we saw just starting out like this. This is what we saw in 3.4 part 1. To solve a quadratic, you get everything to one side. So we're going to minus 45. Okay, it doesn't have a t. So we have 0 equals negative 16t squared plus 32t minus 45. How do we solve that? Quadratic formula. And let's write it over here. Instead of x, our variable's t. So t equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so we're going to simply plug that in. T equals negative b, opposite of b plus or minus the square root of b squared minus 4 times a, which is a 16, times c, which is a negative 45. Okay, a, b, c. Make sure you take the sign with. Okay, all that's under the square root, all over the whole thing. 2 times a, and a is 16. b squared minus 4. 4 is automatically in the equation. A, c. Okay. All right, now we're going to go to our calculator. We could clean this up a little bit, though. Negative 32 plus or minus the square root, and this would be all over 32. Okay. I think this shows up, okay? And I know you don't all have this, but you should all be able to type this into your calculator. 32 squared minus 4 times 16 times negative 45. You should be able to do 32 squared minus 4 times 16 times a negative 45. Okay, and that gives you 3,904. Okay. All right, so now we're just going to split that up. We're going to do negative 32 plus that square root, 3904, and divide by 32. And then we're going to do it one more time, minus the square root of 3904 divided by 32. Okay. All right, so I'm just going to grab my calculator. Negative 32 plus the square root of 3,904. I'm going to hit enter and then divide by 32. Okay, so this gives me, I'm running out of room. This first one gives me 0.95, and that's time, and t is in seconds. So this is seconds. Okay. And then negative 32 minus the square root of 3,904, enter, divided by 32. That one gives me negative, and sometimes that's going to happen. Our equation, sometimes our equation, we get extra answers because this is what happens for an actual parabola, but the whole parabola might not fit our situation. So we just cross this guy out. We can really only have one answer anyways. And there it is, 0.95, so almost 1 second. It doesn't even take quite a second if we're throwing it downwards to go 45 feet. Okay. All right, let's try the next one. If a ball is thrown, now this one's going upward from the ground with an initial speed of 112 feet per second. I don't know why every word problem, they always give us that number, but that number is just showing you where it goes here. Notice the 32 went there. So that's all that's telling us. So don't worry about too much of that because they already kind of put it where it belongs anyways. So if a ball is thrown, now it's going upwards from the ground with an initial speed of 112 feet per second. H is the height of the ball. T is seconds. Okay. H is in feet after T seconds. Okay. So you tell me 2 seconds, I'll tell you how high it is. Okay. You give me 7 seconds, I'll give you how high it is. How many seconds will it take for the ball to fall back to the ground? Okay, so now this ball is thrown upwards, but what happens after it gets to the top? It comes down. Okay, and so we're looking when it hits the ground. Okay, when does it hit the ground? Whenever it hits the ground, it will have gone up and we'll have come down, and that's when we stop our stopwatch, and so that'll give us the seconds. How many seconds? So this even tells us, it doesn't even say how long, it actually says seconds. So we're looking for t. But there's no other number. We use the 112, we know we're looking for t, we know we're looking for seconds, but we don't have anything for height. This one, guys, we got to think. What is the height of the ball if we want to know when it's on the ground? What is the height of the ball if it's on the ground? Well, its height is 0. Its height is 0. So we're going to put a 0 in for H. This one we actually had to think about, but the height has to be 0 if it's on the ground. Okay. Now, we could, if we wanted to, do the quadratic formula. But this one, because this is already 0, this one we can actually factor. Let's see, does 16 go into 112? So 112 divided by 16, and sure enough, I don't know if you guys can see this, but it does go in there 7 times. So one way to factor is we're going to take out, can you guys still see? If you guys, up there, the lights come, maybe you guys can see better with the lights off, but okay. We're going to take out, if this first one is negative, I'm going to take out a negative 16, and they both have a t. This one has 1 t, this one has 2 t's, but I can only take out 1. Okay. So now what is left over? Well, I took out the negative, I took out the 16. This has 2 t's. T squared means t times t. Okay. I took out one of them, so I have 1 left over. Now, I took out a negative, so now we do it all over again over here. I took out a negative, so I have to have a negative there, because what's a negative times a negative? That gives me a positive. 112 divided by 16, we said was 7, and I took the t out. Okay. Now, if we're not sure, we could distribute. If we distribute, we better get these two terms. Okay. If not, we got to go back to the drawing board. Another trick is whatever you think you should take out, you can divide by negative 16t, divide by negative 16t. If you're not so sure about that negative, just literally, you can see that these cancel, and you would type into your calculator 112 divided by negative 16. Whatever I take out, I have to divide by. 112 divided by negative 16 gives me negative 7. And here you can see how everything else cancels. 1t cancels with 1t. Okay. All right, so now we're in good shape, guys. So now either this equals 0, negative 16t equals 0, or t minus 7 equals 0. This is multiplication, not subtraction. What's happening between the 16 and the t, or technically negative 16 and the t? That's multiplication. So we're going to divide by negative 16, and we get 0. Then here we're going to add 7, and we get t equals 7. Time was in seconds. Okay, 7 seconds. Now what is happening here? How many seconds will it take for the ball to fall back to the ground? So it went up, and then it came down. What is this saying? Time is 0. Well, time is 0. This is at the beginning of the problem. Beginning of problem. Okay. When the time is 0, that's the beginning of the problem, and the ball was thrown from the ground with an initial speed. So does it make sense that, yes, it was at the ground at the beginning of the problem, but we want to know what was happening after it was thrown? Okay, so this t0 is just telling you at the beginning of the problem, it was also on the ground. But then it was thrown, and then it took 7 seconds to get back down to the ground. Okay. All right, so there's a little bit of thinking involved here. All right, let's try another one. If a ball is thrown upward from the ground with an initial speed of 80, and notice that goes there, so that they did that for us. Its height is in feet after t seconds. I think these two are very similar. How many seconds will it take for the ball to reach its maximum height? Okay, so depending, maybe we'll just draw this. It goes up, and then it comes back down. Okay. The maximum height is right here. How many seconds? So we're looking for t. We know that we're looking for t. Maximum height, what do we call that when we're talking about a parabola? The maximum height is the vertex. The maximum height on the parabola is nothing more than the vertex. All right, so here we've got h equals negative 16t squared plus 80t. So I just rewrote this. So we know we're looking for seconds. We know we're looking for time. Now, we might think of it, let me just rewrite this. Y equals negative 16x squared plus 80x. So we would always write the vertex as x comma y. So in my problem, this would be t comma h, or in this problem, I should say. Okay, these guys are x's, this is y. So t is the x value of the vertex. How do I find the x value of the vertex? X, which in our problem is t, negative b over 2a. Negative b over 2a. I don't even know, I don't need to know h. I don't even have to plug anything in for h. If I want the vertex of this, I do negative b over 2a. And this number in front of the x squared or the t squared is a, and this number in front of the x or the t is b. Okay, technically my c is 0, but I don't even need a c, which is great. My vertex is negative b over 2a, and that's going to give me the x coordinate, or the t, the time of the vertex. And the vertex is the maximum height. Okay, so it's going to be what? Can we see? Yeah, we can see. T equals negative b, which is negative 80, The opposite of B, you can read that as the opposite of B. 2 times A, make sure you take the sign with, which is negative 16. Okay. And then it's just a matter of typing that into your calculator. There's enough room. You get negative 80 over negative 32. Type that in. Let's see, is that exact? Negative 80 divided by negative, yep, and that gives you 2.5. Okay, 2.5 seconds. How many seconds? So 2.5 seconds. Okay. All right, let's try a few more. Let's try, how are we doing on time? All right, let's try this one. If a ball is thrown upward from the ground with an initial speed of 96 feet per second, its height h is in feet after, oh, we cannot see. Okay, let's start over. That would be helpful. Okay, if a ball is thrown upward from the ground with an initial speed of 96 feet per second, its height h in feet, so the height is in feet and the t is in seconds, is given by this formula. What is the maximum height of the ball? So now we are looking for the height. We're looking for the height. And we have no idea the seconds either. Okay. All right, so this one's going to start out the same as problem 3. Okay. Remember, this is y and this is x. Okay. The x and t's are the same. The y's and h's are the same. But I'm still talking about a maximum. If I'm talking about a maximum, I'm talking about the vertex. So it goes up, and then it comes down, and I want the maximum. That is the vertex. Maximum always goes with vertex. X comma y, or in this problem, it is t comma h. Okay, I'm looking for the height. I am looking for the height. The only thing what I find first though for the vertex is I have to find x first or t first. So I'm going to do exactly what I did in the last problem. I'm actually going to find t first. So it'll be good practice like the last problem. The x coordinate is x or t for specifically the vertex is the opposite of b over 2a. All right, so let's plug that in. Opposite of b, now what is b? The number in front of the squared is a. The number in front of the x is b. Okay, so it's going to be negative 96 over 2 times a, and a is a negative 16. Okay, so we just type that in. You might want to change this. If you want to change this to 32, you can. This gives me, or actually it would be what, negative 32, right? So negative 96 divided by negative 32, and that takes me to 3. Okay, that's great, but I just found t. I need height. For maximum, for vertex, you must always find x and then find h. There's no way to get around. Well, there's some other ways, but this is by far the easiest. So now I know that t is 3. So now I'm looking for h. That'll finally answer my question, but I plug in a 3. I plug in a 3 because I know the time is 3. Now I just have to go find the height. I know the time is 3. Now I just have to go find the height. So this is negative 16 times 9 plus 96 times 3. You must square this first. Okay. So now it's just a matter of type that into the calculator, and you should get 144. Height is in feet, so it's 144 feet. Okay. So for this problem, if I have to find the maximum height, I have to find the time first. So I had to find the time. That wasn't my answer, but I had to go plug that in. Okay. All right, let's try this. Let's see, how are we doing on time? 4, 8. Okay, let's do one more, and then we'll make this part B. Okay. If a ball is thrown upward from the ground with an initial speed of 96, there's a 96, its height in feet after t seconds, okay? How many seconds will it take for the ball to reach a height of 80 feet? Okay. Okay, so what do we know? This time we know an h. The height is 80. We know the height is 80, and the question says how many seconds? That seems straightforward, right? We're going to take this 80, plug it in for h. 80 equals negative 16t squared plus 96t. They gave us a height of 80. Plug that in, and then we're looking for how many seconds, which makes sense. We're looking for t. Okay, so subtract 80. It's a quadratic, so everything to one side. Everything has to be to one side. Negative 16t squared plus 96t minus 80. Has nothing to do with the vertex. Do you see anywhere a maximum, or every once in a while vertex could be minimum? But it mentions nothing about a maximum or a minimum, so now we're not going to do vertex anymore. Okay, we're back to how many seconds? Just in general, if they give us a height of 80, that's back to quadratic formula. Okay, so what is quadratic formula? X equals, or in our case it's t equals, the opposite of b. Let's quickly mark, this is A, this is B, and this is C. Okay. Opposite of b, so negative 96, plus or minus the square root of b squared, 96 squared, minus 4 times a, now just be careful, there's a lot of negatives here, minus a, which is a negative 16, and 80, but that's negative as well, so minus c, which is also negative 80. Okay, so be careful. There's a minus sign in the problem. 16 is negative, 80 is negative. And that's all over 2 times a, which is, again, negative. Okay. All right, so what does that give us? Now let's clean this up. Negative 96 plus or minus the square root all over, and this would be negative 32. All right, so now let's plug it into our calculator. We're going to do 96 squared minus 4 times negative 16 times negative 80. Okay, so I'm just going to type that in there. 96 squared minus 4 times negative 16 times negative 80, and I get 4,096. All right, negative 96 plus that square root divided by negative 32. And then negative 96 minus that square root divided by negative 32. Remember, there's two answers. Plus and minus means you have two answers. Okay, just go to your calculator. Negative 96 plus the square root of 4,096. I'm going to hit enter. Ooh, and I actually get an answer there. And then I have to divide by negative 32, and that gives me 1. All right, let's try this one. Negative 96 minus the square root of 4,096. Hit enter, and I actually get negative 160. I have to do that divided by negative 32, which gives me 5. Okay, now a couple things. If the square root actually goes away, we actually could have factored this, but it might have been a little crazy. I think if we would have taken out a negative 16, we would have been able to factor that. But you may or may not have seen that, and sometimes it's not even worth the time to take it out. But if the square root goes away, it does mean it was factorable. But you have to be really careful with that negative 16 in front. Okay, now, are two answers possible? Let me get a piece of paper here. Well, let me slide this up. Okay, we can still see. All right, so we want to know when the ball was at 80 feet. But if the ball goes up and then comes down, does it make sense that it's at a height of 80 at two different times? We're catching it on the way going up, and we're catching it on the way going down. This height here, height was 80. But over here, we're also going to have a height of 80. Unless we're talking about this highest point right here and said nothing about a maximum, the ball's going to hit a height of 80 going up, and the ball's going to hit a height of 80 going down. What time is it when it hits this 80? The 1 second. 1 second. What time is it when it's hitting the 80 height of 80 on the way down? 5 seconds. Okay, so in this problem, 2 answers are okay. This one's kind of weird. That one, 2 answers are okay because we're talking about it going up and then we're talking about it coming down. It's going to be a height of 80 2 different times. Okay. All right, let's stop there. That'll be part A, and then I'll do a part B, and then you can go do the homework.